Hi guys, Shouvik here. Welcome back to our YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes, so today we have the count of symmetric integers. Okay, so on this question, they have given to us two positive integers, low and high, and an integer x consisting of two n digits is symmetric if the sum of the first n digit of x is equals to the sum of the last n digits of x. Numbers with an odd number of digits are never symmetric. It's very straightforward. So you are going to call a particular number is altogether symmetric if its length altogether is even. So if it is an even length, then you can select first, and let's suppose length is n, then you can select first n by 2 elements and next n by 2 elements, or more specifically I can say first n by 2 digits and next n by 2 digits of the number, and you can sum of the digits. You can sum of the first n by 2 digits and sum the next n by 2 digits. Now the expectation here is the number should be symmetric if the sum of first group and the sum of the second group is identical. The sum of the first group and the second group is identical. Now the point to note that if it is an odd length, then you can't split it, right? You can't split it into two equal halves. You can't split the number into two equal halves which has odd length. So on odd lengths we can't do anything. Now we have to return the number of symmetric integers in the range they have given. Low to high. So on the very first test cases, you can see that low is like 1 and high is 100. So there are 9 symmetric integers, that is of 11, 22, 33, 45. So all of them, like the sum of the first half and the sum of the next half, if you can split it in half group, then it is identical. And on this you can see there are 4 symmetric integers between this and this. So one is 1203, 1212, 1221 and 1230. So here you can see, like the first group consists 12 and the second group consists 03. So the sum of both the groups are identical. So 12 is 3 and 03 is also 3. So I think the question is very straightforward, and you have to return the number of such. You have to return the number of such groups. So mostly there is nothing on this particular question, but you can do standard brute. That also fine. Like you can do standard brute, and every brute, like you can check the conditions basically they are looking for. So I will not take too much time, but I will quickly explain like how you can check it. So if and that's the reason it's tagged also on easy difficulty. So if you know how to like extract the digits of a number, then you should be great. But I have put some few optimizations so that like my submission is more than 95% faster than all the submissions in the Leetcode we have at. So you can see, I guess you guys also notice the constant is like of 1 to 10 raised to the power 4. So you can for sure you can do a iterations. For sure you can do a iterations for each loop. You can run for each loop in where from low to high plus 1. Low to high plus 1. High plus 1 means the last one is exclusive. So low to high we will run a standard for loop. And for every each, when you are going to consider this each, you know your low can be as small as 1 and your high can be as big as 10 raised to the power 4. Your high can be as big as 10 raised to the power 4. So there are two categories of number. There which you have to skip. So with one category having digit length equals to 1, and another category having digit length equals to 3. So these two category we have to skip, because we know by symmetry it is not satisfying the conditions. So we should skip. Now if it is a 2 digit, so how you can skip for one and 3 digits length? It is very simple. If your each is in the range of 0 to 9, then you can skip it because it is odd, or your each is in the range of 100 to, tell me 999, right? 999, then also you should skip. Then also you can do a standard continue. You don't have to do a job on your particular case. And now if it is a 2 digit, how you can check? It should be like in the range of 10 to 99. And what conditions? In 2 digits, what is the point of symmetry? You can split it and the group of first and last is equal. So what elements we have in the group 1? We have single digit, and what we have on the second group? We have the single digit. So both are identical. How we can say? So which are 11 is a such digit, 22 is a such digit, 33 is another, 44 is another, 55. So actually they are just multiplied of 11. So you can check if your each is modular divided by 11 is giving you a 0. If so, then you can say this number is altogether divisible by 11, and if it is a divisible by 11 by like very like base level understanding, it is by default is going to be symmetric. And if it is not, if it is a 4 digit, so that is your first case. So if this case satisfied, then you can increase your answer, or there is another case, you can call and helper functions with the number you have it. Now you have to do like, so now it is a 4 digit number for sure. So on this helper, you can write a very basic checks you can do. You can convert it to string and then loop to the four digits you got, but like a little bit smarter way to do this, like here you can get your nums. So I personally like this, because on if they are playing with the integer part, so you also let's play on the integer. Let's not do the typecasting. So that is kind of a this particular question is more specifically a mathematical operations they are basically looking for. So please stick on the mathematical operations to validate everything, because here you can see, right, I have just put to 10 to 99 check, I have put just 0 to 9 check, I have put just 100 to 999 check, like this way. I can also convert to lane of each, I can convert to lane of string of each I can do, and I can check if it is a odd length string or not. But I am not, because if I am an interviewer, then I also like looking for a complete mathematical like insider, outsider, and divisions, modular divisions, if the candidate is able to solve this. Yeah, so now I got my num. Now how you can check? You know your number should be in 2 category. So you can consider a count variable which is initially as 0, and you can run a while loop to your num until it is exists, and you know what operations you have to do. And now you can consider two part. One is like SM1, another one is like SM2. Two portions of sum we have to finally check. And now let's suppose if your count is less than equals to 1, so that means 0, we have total 4 index, 0 1 2 3. So if it is less than 1, so 0 and 1, so we are checking from last. We are if my number is 1 2 3 4, I will put this first number and this number, so that is 0, that is 1, that is 2, that is 3. So if it is less than equals to 0, so maybe I am considering this, or maybe I am considering this, I will add it. My sum1 is going to be add up with some SM1 plus equals to my num modulo 10. What is the last digit it have as, and else I am increasing my sum2 plus equals to same. What is my num modulo 10? Right? So I will, based on the count, so if it is on considering the from last, if it is a 0th number or it is a 1 number, because I know this should get paired to a single SM1 and this should get paired to an SM2, and if it is so, then I am increasing this. And finally, and after that I have to increase my counter plus, that's the for sure. And what we have to increase, and we not have to increase anything, and I have to divide my number with 10, because that is the way we omit the last digit. Because modular 10 we consider, let's suppose, this digit, and now we don't want to consider it repeatedly, so now we divide it by 10, and my number 1 2 3 4 is boiled down to 1 2 3. So that is the divide by 10 operations, that is the dividend. And finally, if your SM1 is equals to your SM2, then return a true, that is you met the conditions, and otherwise return a false. It is as simple as that, guys. Now let's go to the code once. So here you can see I am iterating a loop for low to high plus 1, and if it is less than 10, then I can say for sure, based on the constant, it is a single digit number. And if it is on 100 to 999, then it is a 3 digit number. We will continue. And if it is a 4 digit number, so that means I will invoke my helper. Or maybe I can do this first. That would be a little bit optimizations, and also follow what we just discussed to our explanations also. So if it is a like 2 digit number, then we will just check with modular of 11. If it is so, then also we are going to increase our answer. Else, that means it is a 4 digit number. And if it is so, I have written the exact same things that I explained. I will take a counter and I am take two variables, sm1 and sm2, and I am doing the same things. Like if it is less than equals to my 1, then I am increasing my sm1, and if else I am increasing my sm2, and for every case I am increasing my counter and divide it with num double divided by 10. And finally I am checking if both parts sum same, then return true, else man return a false. It is as simple as that. And yeah, so that is, I guess, the most optimal time and space complexity for this particular questions. We mostly not using any space, I think, but let's quickly document the time complexity or highlight it. So the time complexity for this particular questions, what low can be 1 and high can be 10 to the power 4 at like very big case. So it is going, if I consider low and high boundary as n, so it is going to take n for sure. And this loop, and inside this only this helper functions complexity we have to calculate. Others we just check with using the this operator, like greater than less than operators only. So that is not going to take any times, but this is going to take this loop is altogether going to run 4 times at max, because for 4-digit numbers it is going to divide by 4 times by 10 by 10 by 10. So it is like 4n kind of complexity, you can say, but it is less, I am believe, but yeah, you can say it is a kind of 4n, 4 into n. And on space complexity, do you feel, guys, we are using any space? Nope. It is on space, we are very good state. We are using constant pace. So that's all about this particular question, most optimal time and space complexity submissions I did. So, and if you guys are able to understand till this point, so please do subscribe to our channel and please turn on the notification. So when we are going to live our next video, you will get the notification as soon as possible. So that's it, guys. That's it for today. Bye, guys. Let me tomorrow with another beautiful question. Bye bye.